the first idea that we need to understand when talking about stereochemistry is the term chirality. Now, a molecule is chiral when its mirror image is non-superimposable with it, not superimposable with it, right? I'm stressing not superimposable. So just like we saw with our hands, our left hand and our right hand are mirror images of one another. So they're two distinct objects that are mirror images of one another. They are non-superimposable with one another. Likewise, I can construct molecules in such a way that some of the times those molecules, when I draw the mirror image of them, the mirror image is non-superimposable with it. And therefore, that type of molecule becomes a chiral molecule. Let's look at a couple of examples. And I'm going to show you first a molecule that is not chiral, and then I'll look at a molecule that is chiral. So in the first example, I have bromoiodomethane. And if I were to draw the mirror image of bromoiodomethane, the way that I have it constructed here, the first thing I do is start off with drawing the mirror image of the tetrahedral carbon, right? And then I say, okay, the bromine is going to be on top because I basically rotated about 180-degree axis. The hydrogens are coming out at me. They're mirroring the hydrogens on the carbon on the left-hand side. The iodine is now on the left because it's mirroring. It's closer to the mirror, just like the iodine on the molecule on the left-hand side. And the bromine goes there. So now I have a mirror image of the molecule that I constructed on the left hand side. So these two are mirror images, and hopefully you can see that they are mirror images of one another. If you can't see that, then you have to certainly get your model kits out to determine whether or not they are mirror images of one another. And now what do I do? Well, now I take my newly constructed molecule and I rotate it around in any way that I can to see if it is superimposable with my molecule on the left-hand side. And for this particular structure, really all I have to do is rotate it 180 degrees. And I see that now the hydrogens are going to go back around. The bromine stays where it is. The iodine goes to the right-hand side. And what do I have? Well, essentially, I now have the same structure that I have as my original structure. And therefore, the two molecules that I constructed are superimposable with one another. And therefore, this is not a chiral molecule. And we call molecules that are not chiral achiral. So achiral molecules are molecules that are not chiral. Now, notice I'm going to show you a slight little deviation from my previous structure, and yet that slight modification can change the outcome certainly radically. I start with bromine. I can even add iodine on. But now instead of two hydrogens, I'm going to change it up, and one of the hydrogens is going to be a methyl group. It could be any group, but let's say it's a methyl group. And then, of course, I have a hydrogen. So now I have one bromo, one iodoethane, and in this particular configuration. Now I'm going to draw the mirror image of it. Again, I'm going to construct it the same way that I constructed the one on the previous slide. I'm going to rotate my tetrahedral carbon. The bromine stays the same because I basically rotated about the axis. The iodine's coming out, right, because I'm essentially mirroring what I drew. And so now the methyl group's coming out at me, and the hydrogen's going behind me, just like in the previous example. Now, I'm going to take that molecule. I'm going to see if I can rotate it around in any way such that it is superimposable with my original configuration. And so in the previous slide, I rotated at 180 degrees, so I could certainly try to rotate this molecule 180 degrees. And I see when I do so, Well, the methyl group swings back. It's now going behind me, and the hydrogen is coming out at me. Uh, the iodine is in the plane of the board, but it's going in the opposite direction. So now I look and I see that, oh, this molecule that I've now created is not superimposable with my mirror image. So it is a non-superimposable mirror image of my original configuration. That is the definition of a molecule that is chiral. We're going to explore this in greater detail, obviously, throughout the chapter. So how are these two molecules then related to one another, right? They're not the same structure. They're not the same configuration. They are different rearrangements of the substituents around that carbon. And whenever you have this type of scenario, we say that the two images, the two structures, are enantiomers of one another, right? So this is a different type of stereochemistry. We have the stereochemistry that we learned with alkenes and cycloalkanes, the cis-trans or EZ stereoisomerism, but now we're learning about a different type of stereochemistry of essentially tetrahedral carbons in which you can have a scenario, and notice the carbon has 4 different things attached to it. This is going to be important later on. And when you have that, there are 2 ways that you can arrange those 4 substituents. And the relationship between them is that they are enantiomers of one another.